let's talk about scientific notation in standard form. You guys haven't seen scientific notation yet in 8th grade, but I'm pretty sure you saw it some in 5th grade and maybe a little bit in 6th grade. So scientific notation is a way for us to write really big numbers or really small numbers. All right, so for instance, if you saw a number written like 3.2 times 10 to the 5th, this is what we call scientific notation. It's some number between 1 and 10 multiplied by a power of 10, in this case 10 to the 5th. All right, this is scientific notation. Now, if we wanted to convert that to standard form, which is how we normally write numbers, you basically use this power of 10 to move the decimal. So 3.2 times 10 to the 5th is scientific notation. To convert that to standard form, we're going to take that 3.2 and we are going to move the decimal right every time we have a power of 10, which is 5 times. So I'm going to move this decimal point right 5 times. So 3.2, I'm going to move it right 5 times. 1, 2, 3, 4, 5. Here's my new decimal point. I'm going to fill in the blanks with zeros. 0, 0, 0, 0. Then I'm going to clean it up a little bit. So I'm going to put a comma here. So this is the same as saying 320,000 in standard form. All right, so 320,000 standard form versus 3.2 times 10 to the 5th scientific notation. They are the same exact number. All right. Now this one had a positive power of 10. What if we have a negative exponent? Say we had 3.2 times 10 to the negative 5th. Well, a positive exponent meant a bigger number. Negative exponents mean a smaller number. All right, and they normally mean decimal values. All right, so if we're going to multiply 3.2 times 10 to the negative 5th power, what we need to do is we need to move the decimal point left 5 places. So I take 3.2. I'm actually going to rewrite it over here towards the center of the page. 3.2. Here's my decimal point. I need to move it left 5. So I go 1, 2, 3, 4, and 5. Put my decimal point down. Fill in the blank spaces with zeros. All right. So I have 1, 2, 3, 4 zeros immediately following the decimal point. So this is the same as saying 0.0000032. This is a tiny number, all right, as opposed to 320,000, which is a pretty large number. All right. Couple details for scientific notation. Perfect scientific notation means that this first factor is between 1 and 10. All right. It's greater than or equal to 1, but less than 10. So for instance, if you saw a number written like, 0.24 times 10 to the 6. That is not in perfect scientific notation because this first factor needs to be between 1 and 10. All right, it's less than 1. So I need to move this decimal to the right to get it between the 2 and the 4. All right, so that takes me to 2.4 times 10. Now, if I move my decimal to the right, that's going to impact my exponent. For every time I move my decimal to the right, my exponent is actually going to decrease by 1. So this is going to become 2.4 times 10 to the 5th power. Now, this is imperfect scientific notation because that first factor, 2.4, is greater than or equal to 1, but less than 10. All right. Another one that you might see something like 24.5 times 10 to the, let's do 6. This is an imperfect scientific notation, again, because this first factor, it's bigger than 10. It has to be greater than or equal to 1 or less than 10. So it really has to be between 1 and 10. All right, it's too big. So I need to move the decimal left All right, so it's going to become 2.45 times 10 to the 7th. So every time I move my decimal point to the left one, I'm going to raise my exponent by 1. All right, that's a very important skill that we're going to use here shortly when we add and subtract numbers in scientific notation. But for right now, the IXL skill that I've given you guys, all you're going to be doing is converting back and forth between scientific notation and standard form. All right, so far we've gone from scientific notation to standard form. You just move your decimal point however many times your exponent tells you to. Now, if we wanted to go the other way, say I had a number written in standard form like, let's do 1,600,000. That's a pretty big number. All right. So let's say I wanted to write this in scientific notation. All right. Right now my decimal point is after that last 0. So what I need to do is I need to get this decimal point between the 1 and the 6. So I'm going to go left 1, left 2, left 3, left 4, left 5, left 6. So I get it between the 1 and the 6. So that becomes 1.6 times 10 to the 6th power. All right. So you'll notice that if you have big numbers, numbers bigger than 1, you have positive exponents. Now what if you have a small number that's less than 1? Like say we had a tiny microdose of something like 0.0000062. All right, this is in standard form, and that's a very small number. Now, since it's a small number, less than 1, I know my exponent, if I wanted to convert it to scientific notation, is going to be a negative. All right, I need to take this decimal point, I need to move it right 1, 2, 3, 4, 5, 6 between the 6 and the 2. So it's going 6.2 times 10 to however many times I move the decimal point. I already forgot. 1, 2, 3, 4, 5, 6. And since the original number was less than 1, my exponent is going to be a negative 6. All right. So that's the basics between converting back and forth between standard and scientific notation. A good rule of thumb is that if you have to move the decimal right, so if my decimal goes right, like I did in this case, my exponent is going to go down. All right, so it could be a negative exponent. If I want to move my decimal to the left, like I did in the first one here when we dealt with 1,600,000, I moved my decimal left, that raised my exponent. All right, that's a good rule of thumb that you won't use too much right away. When we start adding and subtracting numbers in scientific notation, that becomes very important. All right, guys, so to summarize, scientific notation is a way to write really big numbers and really small numbers efficiently. Make sure that first factor is between 1 and 10. All right, if it's something like 24.5, you're going to have to change it. If it's something like 0.24, you're going to have to change it. All right, and last thing, exponents bigger than 1 mean big numbers. Exponents less than 1 mean decimal numbers. All right, so as always, if you have any questions, feel free to shoot me a message on Google Classroom.